Yes.
Good evening. Um, in this video, I'm going to talk about autonomic nervous system, and that will be the aim of the nervous system. Autonomic nervous system simply means it's that it thinks alone without our control. The autonomic nervous system performs its duty without our control. Things like digestion, things like control of heart rate, control of blood pressure, things like urination, things like contraction of urinary bladder, and things like sweating are the functions of the autonomic nervous system. It is called thoraco. It is divided into two: parasympathetic, which is thoracosacral outflow, and sympathetic, which is thoracic outflow. There is another branch called enteric nervous system. That is, they say it is resembling a little brain. It is the one controlling our GIT system. The spinal cord has 31 spinal segments and 12 pairs of cranial nerves. And the sympathetic outflow is organized in a way that you have the receptor, you have the afferent, you have the efferent, and the effector organs. Supposing we have this one, spinal cord, cross section of the spinal cord, and we have the gray matter here. We have the gray matter. We have the gray matter. Supposing we take, for example, the parasympathetic, and we have, for example, the heart here. Heart. Our heart is here. So the sympathetic outflow, parasympathetic outflow, sympathetic outflow will exit the spinal cord through the ventral root to the effector organ. In this case, it is the heart. Okay? Here is the gray matter. The cell bodies are here. The cell bodies of the gray matter are located here, and they exit the spinal cord through this one, ventral root. And again, this is the effector organ. And from here, also sensory fibers, they are leaving the heart and they come back to the spinal cord. They come back to the spinal cord at the level of the dorsal root. This is ventral root. So this is the afferent, and this is the efferent. So it is working in a form of reflexes, in simple. So the action potentials here are initiated here the impulse travels through the efferent, the afferent, they come to this spinal cord, and the impulse travel up to medulla oblongata. From medulla oblongata, they go to cerebral cortex and the other centers, the reticular formation. So this is the simple organization of the sympathetic outflow and inflow. So we have parasympathetic and we have sympathetic. Each is organized so as you have preganglionic neurons and you have the ganglion, autonomic ganglions. They are here. Preganglionic neurons and we have postganglionic neurons. In the case of sympathetic, here what I've drawn is a preganglionic neuron, and the postganglionic neurons are the cell bodies are located in the ganglion, autonomic ganglion, outside the central nervous system. In case of sympathetic, we also have long axons, and we have very short postganglionic neurons, which are located very close to the visceral structures. And the structures such as smooth muscle, the lungs, the heart, the stomach, all are innervated by the autonomic nervous system. You find the receptors. The beta receptors are dominating respiratory system and cardiovascular system. Whereas elsewhere, the most common receptors are alpha 1, and alpha 2. So, in the case of heart, you find that the parasympathetic is decreasing heart rate, whereas the sympathetic is increasing heart rate. In the respiratory system, the sympathetic is dilating the bronchioles and dilating the bronchioles, and it speeds up the respiration. And the nerve endings of autonomic nerves produce neurotransmitters. In the preganglionic neurons, the most common neurotransmitter is nicotine, whereas the postganglionic neuron, the most common neurotransmitter is acetylcholine. So these are the neurotransmitters acting on either alpha or beta. So the noradrenergic outflow and the acetylcholinergic outflow, they are acting against one another. So this is how sympathetic nervous system, autonomic nervous system is organized. Thank you. That is the end of the nervous system.